You're welcome to today's class, and we're starting a new class titled Biostatistics. Biostatistics. However, our biostatistics will be as it applies to public health, as it applies to the medical profession, nursing, pharmacist, medical laboratory sciences, public health, physiotherapy, and so on. Generally, the topic biostatistics over the years, when you watch different videos, audiovisual, or you listen to lectures, it tends to become difficult as complained by students. But I want to tell you this morning that biostatistics is very, very, very easy. We will be demystifying it as much as possible. I will try to make it very easy for you to understand. I will talk about it in such a way that statistics will be loved by, just to use the word, dummies. It will be such that you will enjoy this biostatistics. However, I like you to relax, greet the course with a lot of expectations, be excited at the course biostatistics, and I can tell you, if you wholeheartedly accept this course and tell yourself that you are good, you are intelligent, and that there is nothing you cannot handle, believe me, you will do very well. Right now, we will be going into this biostatistics, and we will start with hypothesis testing in biostatistics. Hypothesis testing in biostatistics. So be rest assured, you will have a wonderful time listening to this lecture. And in the course of this lecture, I have mentors who are so good in this subject. And so it will be a mixed, video, a mixed one, a kind of collaboration. And one of them will be from the Math Tutor institution. I will be collaborating with them with permission to share their video, and you will be watching those videos. By the grace of God, you will understand, and I believe that if you carry out the assignments at one point or the other and you take notes, you will understand biostatistics, the nitty-gritty. We are not going to bore you. I will make sure that what matters is what you hear, what you learn, and there will be one or two examples that you can apply, learning to. So let's go ahead and enjoy this course. Now, looking at biostatistics, we are starting with the first one. And the first one here is hypothesis testing in biostatistics. And we are looking at what are the steps involved in hypothesis testing. How to formulate the null and the alternative hypothesis. We will also be seeing the types of error, that's types of errors in hypothesis testing. That is type 1 and type 2 errors. Then we'll be looking at what does the t-test, chi-square test, and ANOVA for hypothesis testing. What do they mean? How do we apply them? What are their formulas? When do we use them? We will be seeing that specifically. We're not going to bore you. Just enjoy this course. I can tell you it's interesting and you will enjoy it. So let's move to the next slide. Formulating null and alternative hypothesis. Now, when we say null hypothesis, from the word null, you can simply say not, zero. Good. So you can see here, you have the H0 here. From the word null, You have the H0 or H naught at the bottom here. Now the statement, what is null hypothesis? It is a statement that there is no effect, no difference, or no relationship in the population. Now, when we say null hypothesis, it is simply referring to the claim that there is no effect, no relationship, no difference. Take note of the word no in that particular population that we are referring to as statistics. Now, it represents the status quo or the assumption that the data will not show any significant finding. For example, there is no significant difference in the average weight of patients before and after treatment. That is a null hypothesis. We are saying that all the patients who go for treatment, there are no significant difference in their average weight, both before and after the treatment. Now, that is the status quo. That is the assumption that there is no difference, no change, no interference, no relationship. So when you hear that, that is referring to null hypothesis. Now, on the other way, alternative, that is H1 or HA. A lot of persons like to use the HA, that is the alternative hypothesis, from the word alternative. You can see HA, or you use H1. Since this is H0, they just use H1. So for some others, they refer to it as HO and then HA. Now this refers to the statement that contradicts the null hypothesis. Now, the alternative hypothesis is the opposite of null hypothesis. It suggests that there is a significant effect, there is a significant difference or relationship in the population. Take for instance, the example shows that there is a significant difference in the average weight of patients before and after treatment. The first one, no significance. The second one, a significance. HO, HA. So when you say of all these sentences, which of these can be regarded as the null hypothesis? You should be able to spot the null hypothesis. You should be able to spot the alternative hypothesis. You can see clearly there is no, the HO. By liking, you can see that there is no significance. Like HO, it's a null hypothesis statement. Now you have there is a significance. HA, there is a significance, the alternative hypothesis statement. So it's very important that you understand this difference. For the null hypothesis, no effect, no difference, no relationship. For the alternative, you have a contradictive explanation or contradictive statement of it contradicts the null hypothesis. So you see that there is a significant effect, unlike what you have in the null hypothesis. There's a difference. So the claim is opposite when it comes to the alternative, the opposite of the null hypothesis. I think this example is clear enough, and then you can understand that. Now let's move to the next slide. Types of errors in hypothesis testing. Types of errors in hypothesis testing. Now let us start with type 1 error. Type 1 error. You can see that the type 1 error indicated as alpha, type 2 error indicated as beta. Now, type 1 error occurs when the null hypothesis is rejected, while it is actually true. It is rejected when it is actually true. Example, concluding that a treatment has an effect when in reality it does not. You see that? Concluding that a treatment has an effect when in reality it does not. So if you look at that now, you will know that this is a type 1 error. It occurs when the null hypothesis, that is, they claim that it is not true, they claim that it is not It has no relationship. When that claim is rejected, now you are rejecting what is true, meaning something that is a reality, something that is the truth, ended up being rejected. I hope you understand what I'm saying now. So assuming now that the statement is true, that is the null hypothesis, that the relationship, that is concluding that a treatment has an effect when in reality it doesn't. In reality, it does not have an effect. No effect. Null hypothesis, HO, no effect. But you ended up concluding that the treatment has an effect, which is a false positive case. You say that Panadol has an effect for cancer patients. Just as an example, when in reality it has no effect in ameliorating, cancer treatment. But in the research, they concluded that the drug has an effect. Whereas the null hypothesis is that this drug has no effect. It has no effect. So it's very important that you understand that. Now, the opposite is type 2 error. It occurs when the null hypothesis is not rejected, when it is actually false. This is a false negative. I repeat, type 2 error occurs when the null hypothesis is not rejected. Now, when you say it is not rejected, it means, for example, I use this example again. Panadol has no effect in the treatment of cancer patients. Are you getting it now? This actually is true. It's true. It doesn't, because it's not part of the main drugs. It's just for headache and perhaps slight body pain, but the real cancer treatment, you don't use that drug. And so if you look at it, it has no effect. Now, this null hypothesis is not rejected. However, in case it is actually false and is not rejected, then there is a problem. So let's use the right example now. You simply say, perhaps one of the best drugs for cancer treatment is being used for treating cancer, and it's actually the best. And then now, we now say that this drug has no effect on cancer treatment. It has no effect on cancer treatment. Now, what does that mean? Now, that statement actually is false, because this new drug is the best, but the null hypothesis says it has no effect. Now, in the end of the research, the researcher now concluded that the null hypothesis is not rejected. You see that? The hypothesis is not rejected, when actually it is supposed to be rejected, because that drug has good effect, but the null hypothesis says it has no effect. And we expected that after the research, because it is a well-known drug that has effect, the null hypothesis is supposed to be rejected, and then the alternative hypothesis that states that this drug has effect is supposed to be accepted. But unfortunately, the null hypothesis is not rejected, when actually that null hypothesis or claim is false. So this is a false negative, outcome. So example, failing to detect an effect when one truly exists. You fail to detect the effect, the fact that that drug is the best for cancer treatment, when truly it is. So that is type 2 error. Now, one way you will understand type 1 error, simply say that when the null hypothesis is rejected, when actually it is true. So you reject the truth. You see that? That is type 1 error. Why type 2 error is when the null hypothesis is not rejected, when it is actually false. You see that now? So that is that about type 1 and type 2 error. Now, let's talk about significance level. The probability of committing a type 1 error, common values for alpha are between 0.05 or 0.01. So this is the probability of committing a type 1 error, and the common values for significant level is 0.05 or 0.01. That is the point at which you can say that the claim is significant, statistically accepted or rejected. You will come to know that when we go into the calculation. But know that when it is less than 0.05, at that juncture, you decide whether it is accepted or rejected. So you have 0.05 or 0.01. So that is the limit. So now let's see the power of the test. The power of the test. Now this is the probability of correctly rejecting a false null hypothesis. A false null hypothesis. The probability of correctly rejecting a false null hypothesis. Now when we say a false null hypothesis, I give you an instance. For example, the best drug for treating cancer. When you now say that this drug has no effect in the treatment of cancer, you know that is a false null hypothesis. So the probability of correctly rejecting that claim and detecting the true effect is what is referred to as the power of the test. So all that we do in research is presenting two claims, that no effects are not possible, and yes, there is an effect, the null and the alternative. Now the one that is of no effect and the one that is of effect, which of them is true? We don't know. But we want to find out in the course of our statistical analysis, scientific research. So the major aim is ensuring that you do it right, so that you correctly reject the false null hypothesis or correctly accept the true null hypothesis. Again, so that you correctly reject the false null hypothesis and you correctly accept the true null hypothesis. Whichever way you go, you will detect the true effect. So when you say that the null hypothesis, like I've just told you, that the true drug, that drug that is known, we will now want to test it, and we say null hypothesis that drug has no effect on cancer patient treatment, and we know it is not true, but we want to find out scientifically. It is expected that in the outcome of that research, we will end up rejecting. The research will prove to reject evidently that null hypothesis. Now in a case where the null hypothesis is not or is true, like I've told you, cancer drug, that drug has effect, but we say has no effect. That is not true. So in the end, we should reject it because it is false positive. But in the case where the null hypothesis is actually true, Panadol has no effect in the treatment of cancer. In the end of the research, we should, just as an example, so don't get me wrong, Panadol has no effect. I'm just using that as the list. Who uses that for treatment of cancer? Now, that null hypothesis is expected that at the end of the day, it is not rejected, because in the actual sense, it is true that Panadol has no effect on cancer patients. So it should be accepted, that's not rejected, that null hypothesis, because the statement is that statement is true. So try and get it clearly. And I've given you two examples there. The type 1 error, concluding that a treatment has an effect when in reality it does not. Type 2 error, failing to detect an effect when it truly exists. So you can only find a type 2 error when you fail to detect the fact that this good drug is good in treating cancer. Failing to detect it when actually it exists is type 2 error. Concluding that it is good, that it has an effect when in reality it does not, is type 1 error. So in conclusion, listen to this last statement now. It will help you nip it on the board. Anytime you hear that in the real sense something is not true, but the research concluded that it is true, in reality it is not true, but that research concluded that it is true, that is a type 1 error outcome. You get that? When something in reality is not true, it is not true, but the end of that research concludes that it is true or it has effect, that is a type 1 error. Then type 2 error is when you fail to detect an effect when actually it does have an effect. That is type 2 error. So the first one is you conclude that it is true when it is not in reality, type 1 error. Type 2, you fail to detect that it is true when actually it is true. I'm sure with this detailed explanation I've given, you will now understand what type 1 error and type 2 error is. Now let's move to the next topic. Test of hypothesis testing. Tests of hypothesis testing. You have the t-test, and then you have the chi-square test, and then you have the ANOVA. We will talk about that later on as we go on. Under the t-test, the t-test is used to compare the means of two groups or conditions. When you have two groups that are under statistical check, two groups, maybe boys and girls, you want to compare any two groups, the means, those two groups would have been calculated to know their mean so that you can deal with something. You cannot just use all of them. That's why you have your mean median mode. Now, it's used to compare the means of two groups or conditions. What are the types? What are the types? So, let us see the types. You have the one sample t-test. You have the independent two sample t-test. and you have the paired t-test. Now, these are various ways of now proving the claim of whether to reject or to accept the null hypothesis. Now, when you accept the null hypothesis, it simply means we are rejecting the alternative hypothesis. And when we reject the null hypothesis, we end up accepting the alternative hypothesis. Now, as it stands, there are various reasons why each of this is used, whether one sample t-test, independent two sample t-test, or paired t-test. For one sample t-test, it will compare the mean of a sample to a known value. The mean of a sample to a known value. For example, what is investigated to the known control. In the case of independent two sample t-test, it compares the means of two independent groups. Two independent groups. We want to see the relationship between the two of them. Is there a significant relationship? Is there really an association between the two to give a meaningful impact? Or is there a causal relationship such that without one there cannot be the other? Or that the two of them, if they don't move together, or they are not accepted together, or they are not associated together, you probably won't find any meaningful output. So, two independent groups. Now, the third one, we use it when we compare means from the same group at different times, that is, before and after treatment. So, we are comparing 3 drugs or 2 drugs. We are wanting to see the effect of these drugs in this set of animals before and then after. So you are comparing the means, that is representation of these 2 same group at different times. For example, same groups. For example, this particular group, they were exposed to this before. We check what it was, and then the environment, the exposure was now changed to something else. We now want to see what is then the effect before. We've checked, after we have checked. So you are dealing with the same group but different times. Exposure might be the same or might be different, but the same group and at different times. Now let us see the chi-square. This is used for categorical data to test the relationship between 2 or more categorical variables. Now, to understand the chi-square test, how or when it is used, we need to first of all understand what is a categorical data, because you need to know these data. You need to know them when you see them to identify your variables, your categorical data or categorical variables when you need to use them. Because if you don't understand, you don't recognize them, you cannot use them. So in the next slide, we will be seeing what are categorical data. What are categorical data? Now, categorical data are variables that represent categories or groups, and they can be further divided into nominal and ordinal categories. So categorical data appear in 2 ways or 2 categories: the nominal category and the ordinal category. Now let's look at the nominal category, that is the nominal data. When you say nominal data, one spectacular trait about them is that there is no inherent order. There is no specific order, no, as it were, natural law of order. It is non-inherent. You have, for example, gender, male, female, non-binary. You could have marital status. That is a nominal data. Single, married, divorced, widowed. You have them maybe in your research. Blood type A, B, ABO, or the eye color. Nationality, a Nigerian, American, Indian, Chinese, or animal species. Dog, cat, elephant, tiger. Now these are nominal data. No inherent order. Very spectacular. You can see this for yourself. Good. Now when you now look at the ordinal data, when you look at the ordinal data, you will find out that one, it has a specific order or ranking. A specific order or ranking. For example, educational level. It begins from high school, associate degrees, bachelor's degrees, master's degrees, PhD. Now you have satisfaction rating. Very unsatisfied, unsatisfied, neutral, satisfied, very satisfied. Health status, you want to rate it. You begin with poor, fair, good, excellent. Poor, fair, good, excellent. Now when we talk about customer rating, you know it comes in rating, like the word rating. There are levels. You have first star or 1 star, 2 stars, 3 stars, 4 stars, and so on. How about socioeconomic status? When you are dealing with demographic data, you want to know the socioeconomic status of that population. Low income or low level in the society, middle level in the society, high level or high influence in the society. Every man comes at different levels naturally in life. So you look at that. You want to use that to rate the people in that population so that you can know the level of influence that they wield. Perhaps everybody in that community is of a high socioeconomic status. They earn more, they are well known in the society, they have great capacity to make influence, and so on. Now, having known that, let's now go back to the chi-square. It's a use of categorical data to test the relationship between two or more categorical variables. It could be ordinal or nominal. Now, what are the types of chi-square? You have the chi-square test of independence, that is test of two categories. The test if two categorical variables are independent of each other. We want to see that if these groups, these categorical variables, actually are independent, the other can be without the other. They don't need each other to be able to provide an outcome. Each of them can independently provide an outcome without necessarily associating them. Why? For the chi-square goodness of fit test, you use that if a sample data matches an expected distribution. If a sample data matches an expected distribution. So what is the assumption here? That large enough sample size, expected frequency in each category is greater than 5. Large enough sample size, expected frequency in each category is greater than 5. So it's expected that before you can do this test, there is enough power size, enough sample size, and then you also have that there is an expected frequency from each category that is greater than 5 in terms of the count of the categories you are dealing with. They must be greater than 5. Now let's see the third one. That's the next one after t-test, chi-square test. Now let us talk about ANOVA. Let's talk about ANOVA. That is analysis of variance. It is used to compare means across 3 or more groups, but in chi-square we are talking about 2. Remember, look at it again. We are talking about relationship between two or more categorical variables. However, test if two categories. You see that? If two categorical variables. That's mostly what we do there. But in ANOVA, it can take as many, comparing many across three or more groups. You have the one-way ANOVA. One-way ANOVA. This tests the difference in means across multiple groups based on one independent variable. Now you will need to understand what are examples of independent and dependent variables. So when you have more than one dependent variable or independent variables, now you want to test the difference in the means across the multiple groups based on one independent variables. Now we are using one independent variables to check, to test across all the multiple groups, to test the difference in the means, and we are using based on one independent variable. So we want to find the difference here against this group, against the other group, against the other group. What is then the difference? Is it significant or not? We have the two-way ANOVA. This is where we test the difference in means across multiple groups based on two independent variables. We are now checking out for two independent variables across many groups, across multiple groups, to test the difference in their means. And what is the assumption here? That the distribution is normal and that there is equal variances across the groups. Don't worry, like I told you, this discussion will be in collaboration with other great mentors, great statisticians, and we'll be watching the video, watching the audio visual, and learning in detail these calculations. So relax, don't be worried, you will know it fantastically. But understand the theory, the framework behind it, so that when we start discussing it, as you watch, you will understand it in depth. Now let's see examples of independent and dependent variables, so that when you see them, you can recognize them and you can utilize them. Now, in medical research, as we are doing in medical research, an example of independent variable includes type of treatment. Type of treatment: drug A, drug B, or you are using a placebo, a drug without any effect, but just to improve the psychology of the patient, believing that he or she has been given a drug. And so we know that that drug is just a carbohydrate, or probably just a glucose. It's not really having any effect regarding that drugs, so let the person just go. But the person, because of psychological feeling, he feels he's taking the right drug, and you just see him getting well and better. So that's that type of treatment. Now, two, dependent variable: patient's recovery rate. Example: percentage improvement in symptoms. Because dependent variable actually don't stand on their own, they depend on other things. So a patient recovery rate will actually depend on the treatment, which is observable by the percentage improvement in the symptoms. It came with 6 symptoms. Now the symptoms is reducing to 3, gradually reducing to 1, and gradually there is no more symptom. That way you can say a patient has recovered properly. Number 2, let's look at education. In research within education, an example of independent variable can be said to be study method, online learning, classroom learning. Just like you are learning now online, and when I come to class, that is the classroom learning. Physically, I teach you, I take your question and answers if there are, or I summarize, or I provide deeper explanation to areas that appear to be tough, so that I can simplify it. That is kind of independent variable in research. But the dependent variable is the student exam performance. The student's performance will be dependent on how much you understand these lectures, how much you are, committed to learning, how much you are committed to doing your assignments, submitting at the right time, attending classes, and making sure that you go through your audio visuals to learn. So student exam performance, that is dependent on something. But online learning, classroom learning, it's independent as a variable. Let's still see others. In agricultural field, you have independent variable. For example, amount of fertilizer applied. That's fertilizer. We have to apply fertilizer. But the dependent variable is the crop yield. Example, the kilogram of produce per hectare. It will be dependent on the fertilizer that is applied and the way and manner that plant is, the process is carried out. So a lot is dependent in the crop yield. Number 4, psychology. You have independent variable. The amount of sleep. Example, you sleep 4 hours, 6 hours, 8 hours. That's an independent variable. But that's as a dependent variable, dependent now, cognitive performance, that ability to react in a test. When you sleep well, you have a good cognitive level. You can think, you can react, you can respond, you are sharp at what you do during the day. So that sharpness, cognitive performance, is actually dependent on the proper amount of sleep that you've had. Number 5, in business research, independent variable. You are advertising a budget $1,000, $5,000, $10,000, but the dependent variable is such that sales revenue. Now, when we say sales revenue, this is dependent on the total sales per month. How much you make that month is dependent on your sales. But when we are advertising, the budget is not dependent on that. We advertise believing that you will have good level of total sales that month. The next one is social science. You have independent variable socioeconomic status, high, middle, or low. But the dependent one is health outcomes. The health outcome or life expectancy or lifestyle is dependent on the socioeconomic status. For environmental science, an independent variable includes pollution level. Example, the amount of CO2 in the air. Now for the dependent variable, plant growth. Example, height of plants after 6 weeks. It will depend on the richness of the oxygen, the richness of the light in that community. And so it is important that you understand this. How about sports science? A clear independent variable is the type of exercise, weightlifting, cardio, and all that. But dependent variable can be said to be muscle mass. The more you exercise, you improve your muscle volume, you increase your muscle volume, 6 packs, 10 packs. It all comes by the level of input. You hit it hard in your exercise, it develops the muscle more harder. Bodybuilders even go to the extent of taking drugs, steroids. You see the effect after few months. Having said all this, what is our takeaway? What is our takeaway? One, that independent variable, the independent variables are variables that you manipulate or categorize in an experiment to see its effect on another variable. You manipulate those independent variables. You manipulate them or categorize in an experiment to see its effect. For example, when you see here, you manipulate this socioeconomic status to see the effect on health outcomes, to see the effect on life expectancy. You manipulate the amount of fertilizer applied to see the effect on crop yield. So that's the difference. Now in dependent variable, the variable that is measured and expected to change when it responds to the independent variable. Now, this tells you that there's a relationship. You manipulate the independent variable to find or see the effect on the dependent variable. So the variable that is measured and expected to change in response to the independent variable is the dependent variable. Like the word dependent is depending on the impact of the independent variable to show its effect, to respond. So that is that. Now let's go further to see the summary of what we have learned today. And I must tell you, biostatistics is simple. You just need to understand. And that's what I want you to do, please. We have stated the hypothesis, and we have said null hypothesis HO from the word not, no, O, not, zero, null, zero. And then the alternative hypothesis, I mean A or 1. So you can say null hypothesis HO or H0, alternative hypothesis H1 or HO, alternative hypothesis HA. That's number one. Number two, we have seen how to choose the significance level. Typically 0.05, which represents 5% risk of committing a type 1 error. 5% risk of committing a type 1 error. That is, I've told you type 1 error and type 2 error. The first one is true, and then you rejected it. The second one is true, but you fail to recognize it. So it's very important that you take note of that. Please go back, go through the type 1 error and type 2 error. Very, very, very easy. Now for 3, select the appropriate test. We have seen that you choose between t-test, chi-square, and then ANOVA based on the data type, the variables, categorical variables, nominal or ordinal. So these are the type of data, nominal or ordinal, categorical data, and so on. So these variables, I've shown you examples. Now you understand the independent and then the dependent. When you see them, you can identify which one is independent, which one is dependent, actually depending on the impact of the independent to express the response. Now number 4, we have seen calculating the test statistics. The use of formulas to compute the test statistics. Example, t statistics, chi-square value. And then number 5, to determine the p-value. That is, the p-value indicates the probability of observing the data under the null hypothesis. And we have seen that when p is less than equal to alpha, you reject the null hypothesis. When the p-value, the p-value which indicates the probability of observing, if it's less than or equal to the outcome, you know that you reject the hypothesis. And when you reject the hypothesis, that is the null hypothesis, that means that you accept the alternative hypothesis, stating that we are rejecting the null hypothesis because it is not true. What is true is the alternative hypothesis. Now we see also the summary steps in hypothesis stating. You draw a conclusion. So, if the null hypothesis is rejected, conclude there is a significant effort. If the null hypothesis is not rejected, conclude there is no significant effect. So interpret the results. Discuss the implications of the results in the context of the research. Oh, sorry. Let me take it again. Sorry. I hope this is not fatigue. Okay. Now let's start again. In this place, we want to summarize the steps of hypothesis testing. The steps. Now there are steps in, you want to carry out hypothesis testing now. So sorry, please. Now let me take it all over this particular slide. In this slide, we want to analyze the steps in carrying out hypothesis testing. Number 1, we are going to start by stating the hypothesis. What is your claim that Panadol is not useful in the treatment of cancer. That's the null hypothesis. And the alternative hypothesis is Panadol is useful in the treatment of cancer. If you check it, we now want to prove statistically whether it is true, the null hypothesis, or the alternative hypothesis is true. All right, so sorry for that intercession. Let's just continue from here. So like I said, first you have to state your hypothesis. The first one is your null hypothesis, and like I said, the second one is your alternative hypothesis. And so in reality, if your null hypothesis is rejected, that's in terms of your error 1, type 1 error and type 2 error. In type 1 error, you rejected the null hypothesis, but it is true. You rejected it, but it is true. So that creates a false positive result, outcome. Then the second one is that you failed to reject the null hypothesis, but it is false. So that gives a false negative. So it's important that you note it. Now for the second aspect, you choose the significance level. Now, this research you want to do, what will be your significance level? At what point do you agree or accept that your outcome will be significant? Typically, we use 0.05, which represents just 5% of the risk of committing a type 1 error. And like I told you, what is the risk of committing a type 1 error? That is, you rejecting the null hypothesis when in actual fact it is true. So we are rejecting the hypothesis that states that a particularly known good drug, efficacious drug for cancer treatment, stating in the null hypothesis that it has no effect on the treatment of cancer. You know clearly that in reality it has effect, but the null hypothesis is saying it has no effect. So in that case, it's expected that we will reject it. Now, assuming now we now have a drug that, let me say, it's very, very good. And then the claim of the null hypothesis say it has no effect. And you end up accepting it. You fail to reject it. Then there will be a problem. Now that kind of error is what we are trying to prevent. And what error is that? Rejecting the null hypothesis when in the actual fact that claim is true. Number 3, you go further to select what appropriate test are you going to use for this analysis. Is it the t-test? Is it the chi-square? Is it the ANOVA, the analysis of variance? Now this is based on the data type and hypothesis. And I've told you the different type of data. We've seen the categorical, we've seen the ordinal, we've seen the nominal, we've seen the variables, independent and the dependent variables. You should be able to recognize them when you see them. Then number 4, having seen that, I've told you t-test, the variances that is check chi-square, 2 or more, groups, and over many groups, but this time you are either doing one way or two way. That's the one way you are now checking one independent variable across those groups, or two way we are testing 2 independent variables to see the impact on all those groups, in as much as they are exposed equally and then they have the equal significant chance. So you want to check using which of them. So you can start with your t-test, you can start with your chi-square the moment it's now beyond one group. You have 2 groups or 3 groups, and over many groups, so many groups, and you are dealing with one independent variable, same population, but checking different things. So that is that. Now number 4, you now want to calculate these test statistics. Now, in calculating these test statistics, you use formulas to compute the test statistics. Example, t-statistics or chi-square value. Number 5, you determine your p-value. And I've told you, if your p is less than or equal to your outcome, then you reject the null hypothesis. And when you reject the null hypothesis, you want to be sure that there is no type 1 error, that you don't reject the null hypothesis when in actual fact, in reality, it is true. Number 6, you draw a conclusion. If the null hypothesis is rejected, then you conclude that there is a significant effect. I repeat, if the null hypothesis is rejected, then you conclude that there is a significant effect, meaning that the alternative hypothesis is what is accepted. Now, if the null hypothesis is not rejected, you conclude that there is no significant effect. Why? Because for the null hypothesis, it is this has no effect. Then for the alternative, it is a conclusion that this has effect. So if I reject the null hypothesis, then I'm concluding the alternative, which says that there is an effect. Now, if I accept the null hypothesis that is not rejected, it concludes that the alternative effect is not invoked. That's not what is accepted. Therefore, the null hypothesis is of the acceptance, and meaning that in conclusion, actually what we tested for, there is no significant effect. Finally, you interpret your results. So you discuss the implications of that result in the context of your research question. It's as simple as that. Listen to me. The biostatistics is a very simple course. All you just need to do is don't cram. Do not cram. Understand it. I've broken it down to you. Get the theory right. If you get the theory right, believe me, you will enjoy this course. Now, if you greet this course with some kind of misfeeling, you've always heard it's hard, you've always heard it's difficult, in fact the lecturers are difficult. Of course, if you know that I presented this course in a difficult pattern, just go down there and write it on the comments. You will barely see anybody writing that. The truth is, if you are committed to it, you greet this biostatistics with the mindset that is as easy peasy the way you eat your food. That mindset already deals with it. And don't try to take the whole chunk at once. Just take it one by one. State the hypothesis. Choose your significance level. Don't worry about 3, 4, 5, 6, and 7. Deal with that number 2 first. Once you have chosen, you move to the next one. Select your appropriate test. You've done that successfully. The next one, calculate the test statistics. You're not doing it off-head. You have the statistics there. You already know the variables. Take them one by one. Easy peasy. Go to the next one. Determine the p-value. And after that, draw your conclusion. You are not making anything up. You are not cooking anything. Your result comes out based on the rules. You reject or you accept. Very simple. You draw your conclusion. And then finally, of course, you did the research. I can't interpret it on your behalf. You knew what you were doing. You had a research methodology. You had an introduction. You discussed it. You proved why you wanted to do this research. So you should be able to discuss the implication, because right from the word go, we were waiting to see whether there will be an acceptance or a rejection. And whatever the conclusion is, there is always an explanation to that implication. So you go ahead, you discuss that implication, get the explanation known to us, and prove to us if indeed there was no error to that effect. But what you should understand, that there are some things you don't prove. For example, how do you prove that the null hypothesis, water, has no impact to life? Water is not good or does not help in growth of the human body. So if you end up accepting that null hypothesis, I'm sure you know you can't defend that. So that's a simple example. You know that automatically is a type 1 error. Type 2 error. You fail to reject it, when in actual that hypothesis is false. But we all know, but we just have to prove it scientifically. Is water of any impact to life? So the null hypothesis will be of no impact. So if you end up having a acceptance and your null hypothesis is not rejected because it is P greater than the outcome, and so you accept the null hypothesis, what it means is that there's a problem in your test. Go back and check. It's not just garbage in, garbage out. That's why you need to understand the theory. You will know that something was actually wrong. To prove it, you have to double check again and again. All right, so with this, we've come to the end of this class, exactly 59 minutes. And I'm sure that we've done justice to this. Thank you for listening. Like this guy here, you have to listen again and again. You pause when you need to pause, and then you listen, and then you take notes. And remember, there are assignments. You take those assignments down. You find that in the Google Classroom. Be ready to do this assignment and submit within the 24 hours notice. Once you submit after the 24 hours, you know it is locked. You can't submit again. And you remember the rule, ethically, you have to do what is right. So in this course, we have just concluded hypothesis testing in biostatistics. We've seen what are the steps involved in hypothesis testing. We've seen formulating null and alternative hypothesis. And then we have also seen the types of error in hypothesis testing, type 1 and type 2. And I've discussed the QT-test, chi-square test, and ANOVA for hypothesis testing. If you have any question, make sure you ask on the Google Classroom, and make sure you make sense when you're asking your question. I'll see you in the next class. Bye.